Welcome back to my channel. I'll be starting a series on how to plot the graphs of different functions, starting with the graph of the function y equals to x, which is this one here. So y equals to x is the identity function, and starting from that identity function, I will be discussing the functions like x squared, x cubed, that is raising the powers to even numbers. And these y equals to x, y equals to x square, y equals to x cube, these graphs can be generalized into the graphs of these, which are y equals to x power 2n, which are the even powers, and x power 2n minus 1, which are the odd powers. Also, I will be discussing the graphs of rational functions. So these y equals to x, y equals to x square, these are all the algebraic functions, or moreover a polynomial functions. Here we have the rational functions. Rational function like this y equals to 1 by x, y equals to 1 by x square, y equals to 1 by x cube, and generalizing them we get y equals to 1 by x power 2n, 1 by x power 2n minus 1. Also, I'll be discussing the rational functions, and after that we have these irrational functions. Irrational function means x power half, that is root over x. Next is x power 2 by 3, x power 1 by 3, which are the cubic root of x. And also here we have the generalized version as x power 1 by 2n, which are the even terms, and x power 1 by 2n minus 1. Next, moving to the piecewise functions. So for piecewise functions, here we have y equals to mod x, which is the modulus function. Next, we have this mod x by x, which is the signum function. Next, we have the fractional part functions, which is written in the second bracket. Here we have the greatest integer function, and followed by it the least integer function. Next, we have here the trigonometric functions and their inverse trigonometric functions, like here we have sin x, cos x, tan x, sec x, cosec x, tan x, cot x, and their inverse trigonometric functions, which are sin inverse x, cos inverse x, tan inverse x, sec inverse x, cosec inverse x, cot inverse x. Next, we will be discussing the exponential functions. Exponential functions means y equals to e power x, y equals to a power x, where a is greater than 0. And also we have the logarithmic functions, which are log x, log x base a, and here we have a greater than 0, this condition. Okay, so what will we discuss about the graph of these functions? So the main properties which we will discuss here are the x greater than 0. So what does x greater than 0 means? X greater than 0 means it is the positive x-axis. So how does the function behave in the positive x-axis, that we will discuss. Next is x less than 0. So how does the function behave in the negative x-axis, even or odd? So whether the function is an even function or an odd function, this will also be discussed. Also, whether the function is increasing or a decreasing function, and its behavior at x equals to 0, x equals to positive infinity, as well as x equals to negative infinity. And also the domain and range of each of these functions. So, though here I am saying it about prior knowledge, so there is no need for any prior knowledge, as I'll be discussing all the things during each of the graphical presentation of those functions. So here we need to discuss about limit, the definition of limit, like limit x tends to 0, what does the limit properties, limit different kinds of limit formulas. Same with continuity, derivative, the derivative, how to calculate the derivative of a function. Next is increasing property, decreasing property. Those are derived using the derivative, and also whether the function is even or not, which we can easily calculate. Now, what is our aim after we discuss the graph of these functions? So from the graph of these functions, we want to directly conclude about the limit existence of their limit at different points, its continuity, whether the function can be continuously drawn or there are some breaks, and also the differentiability, whether the function is smooth or not. Also its domain and range. So domain and range plays a crucial role in mathematical analysis of these functions, and also some equality questions like if we consider this one, sine x equals to half. So obviously we can calculate it using the normal calculation techniques, but we can also solve it using the graphs, and also inequality questions like sine x less than half. So for these inequality questions, we will obtain different regions. So we can also conclude those inequalities using the graphical techniques. So please watch my full playlist for the upcoming videos on graphs of this function. Thank you.